Dart School presents adding and subtracting decimals. In a decimal number, you can add as many number of zeros as you want in the end of the number and the number doesn't change. For example, 0.5, the decimal number that's equivalent to 1/2, is same as the decimal number 0.50, and that's the same as 0.500 and so on. And you can actually explain this using the idea of equivalent fractions. If you look at the first one, it's like saying it's 5/10. The first place after the decimal point is called the tens place. So this is called the tens place. Similarly, this decimal number is equivalent to the fraction 50/100. And this one is equivalent to the fraction 500/1000. The first place after the decimal point, as I already said, is called the tens place. Then you have the hundreds place, and then you have the thousands place, and so on. And if you look at these three fractions, 5 tens, 50 hundreds, 500 thousands, they are all equivalent fractions. They're all equivalent to 1/2. Reason why? We could say that all these decimal numbers are the same. And you could add as many number of zeros in the end as you want. It's still equivalent to the fraction 1/2 or the decimal 0.5. And we can actually use this property of decimal numbers to add or subtract decimal numbers. The key is to have the same number of digits after the decimal point on each one of the numbers you're adding or subtracting. If required, feel free to add zeros to the end of one or more of those decimal numbers so that they all have the same number of digits after the decimal point. And before you start adding or subtracting them, make sure the decimal points are aligned. The decimal point of one number is right below the decimal point of the number above it. Let's look at a couple of examples now. Let's say we want to add the decimal numbers 1.3 and 5.28. As we see over here, there are two digits after the decimal point in this number, but there's only one digit. So our first step is to add a 0 so that they both have the same number of digits after the decimal point. And then we write down one number just below the other and the decimal points aligned, 1.30, 5.28, the decimal point one below the other, and then add them up. The decimal point on the answer is right over there at the same position. 8 plus 0 is 8, 3 plus 2 is 5, and 5 plus 1 is 6. So the answer is 6.58. Let's try another one. Let's do 65 plus 0.9 plus 4.37. Now, if you look at 65, there's no decimal point. It's an integer number. On an integer number, the decimal point is right in the end. 65 is nothing but 65.0. And if you look at the other two numbers, 4.37 has got two digits after the decimal point. And therefore, we need to add another 0 over here to make it 0.90 and another 0 over here so that all three numbers have the same number of digits after the decimal point. The rest is easy, I guess. Let's write down 65.00, 0.90, and then 4.37, and just add them up. The decimal point on the answer will be over here. 0 plus 0 plus 7 is 7. 9 plus 3 plus 0 is 12. Write down the 2. Carry the 1 over. 5 plus 1 is 6. 6 plus 4 is 10. 0 comes in here. 1 carried over. 6 plus 1 is 7. The answer is 70.27. Let's now do a subtraction problem. Let's say we want to do 4.8 minus 4.68. Now many students who start learning about decimals tend to think that 4.8 is less than 4.68. But it isn't. If you look at the two numbers, there are 2 digits after the decimal point on 4.68. So if you want to have 2 digits on 4.8, you would add a 0 to make that a 80. And 80 is larger than 68. Okay. So to subtract them, write them down. 4.80 minus 4.68. The decimal points aligned. The decimal point on the answer will be here. So 10 minus 8 is 2. You had borrowed 1. Therefore, the 8 changes to a 7. 7 minus 6 is 1. And 4 minus 4 is 0. The answer is 0.12.